Hello, everyone, and welcome to Operations on Radicals Lesson 4. I've got the screen blown up or zoomed in pretty far because I just want enough space to solve these. And when I write with my pen, it's a little bit chunky, so you should have enough space, but I apologize for it being so zoomed in. So today we are going to continue dividing radicals, but in this part we are going to make it a little bit harder, or we're going to look at a little bit more of a complicated examples, but it's totally doable. So let's jump in. So today we are rationalizing a denominator, but in binomial form. So in lesson 3, we looked at rationalizing a denominator that had only one term in the bottom. And now we're going to look at rationalizing the denominator when it's got two terms in the bottom. So hopefully you remember from one of our units we looked at multiplying by the conjugate. So we are going to use this idea to rationalize the denominator. So let's jump into example A here. We have 2 divided by root 5 minus root 3. So first of all, what we want to do to rationalize the denominator is get rid of any square root signs in the bottom of our fraction. So you can see we have a square root 5 and a square root 3. We need to get rid of both of those. And the way we're going to do it is to multiply both top and bottom by the conjugate of the binomial. So I'm going to multiply top and bottom. So the conjugate, if you remember, is of root 5 minus root 3 is going to be square root of 5 plus the square root of 3. And you have to multiply both top and bottom because that way you're really just multiplying this term here by 1. And if you multiply anything by 1, you're not changing the value of it. So we're allowed to do this. It's going to rationalize that bottom without changing the value of the expression. All right, so now that we have this, we want to multiply our tops together and multiply the bottoms together. So if you look at the top, I'm just going to scroll a little bit. So in the top, we have 2 multiplied by everything in the top of the fraction. So 2 multiplied by root 5 plus root 3. 2 multiplied by root 5 plus root 3. And then in the bottom, what we want to do is we want to multiply everything in this bracket by everything in this bracket. And so we are going to use our FOIL. Hopefully you remember FOILing. So when we multiply 2 binomials together, we use FOIL, which stands for first, outside, inside, last. So what you're going to do is you're going to multiply the first 2 terms together. So the first 2 terms in each bracket are root 5 multiplied by root 5. And we know when we multiply root 5 by root 5, we end up with 5. And then we are going to multiply the outside terms together. So we have root 5 multiplied by positive root 3 is going to give us positive root 15. And then the inside terms, negative root 3 multiplied by positive root 5 is going to give us minus root 15. And then finally the last term, so negative root 3, multiplied by positive root 3 is going to give me negative 3. So what happens when we rationalize the denominator by multiplying by the conjugate is you can see that the first term in the bottom is a whole number, and then the middle 2 are still in radical form, but they end up canceling. If we have a positive root 15, subtract root 15, that ends up canceling out, and then the last term is a whole number, so we can just leave it. So in the bottom, I have 5 minus 3, and in the top, I can factor in or multiply through that 2. So now I have 2. Actually, you know what we can do is we can leave it out. So let's do that. What we can do, so I'm going to backtrack a bit. There's a simpler way to do this. We'll leave it out. Normally we would multiply it through, but it's going to be faster to just look at the bottom first, because now we have 5 minus 3, and 5 minus 3 gives us 2. So if I have 2 over 2, we know that that's going to cancel, and I'm left with root 5 plus root 3, and that's my final answer. I don't have any square roots in the bottom of a fraction, so we're done. That's awesome. So now what we want to do is example B. So we see that we have root 6 minus root 2 divided by root 6 plus root 2. It's okay that we have square roots in the top of that fraction. That's fine. What we don't want is square roots in the bottoms. We're rationalizing the denominator, or the bottom of the fraction. So when we do that, we want to multiply by the conjugate of the bottom. So the conjugate is going to be the same expression, but instead of a positive, it's going to have a negative. So root 6 minus 2. And then we're going to multiply the same thing to the top, root 6 minus 2. And now what we can do is, let's multiply those out. So in the top we have, let's do the top here. We're going to multiply those brackets by those brackets. We're going to use FOIL, first, outside, inside, last. So we're going to start with first, which is root 6 multiplied by root 6, and that just gives us 6. And then the outside is going to give us root 6 multiplied by negative 2, which will be negative 2 root 6. And then the inside is negative 2 multiplied by root 6, which will give us another negative 2 root 6. And then finally, the last terms is a negative 2 multiplied by negative 2. That gives us a positive 4. And now we can do the same process with the brackets underneath. So we have root 6 plus 2 multiplied by root 6 minus 2. So we can say root 6 times root 6 is 6. Now we're going to do the outside term. So root 6 multiplied by negative 2 is minus 2 root 6. And the inside terms, plus 2 multiplied by root 6 is positive 2 root 6. And then positive 2 multiplied by negative 2, the last terms, gives us negative 4. And the idea, again, is to get rid of any root signs in the denominator, and we can see that we have negative 2 root 6 plus 2 root 6, so they end up canceling out. So now I can rewrite this as 6, and on the top I'm going to combine these two together as well, because I have negative 2 root 6 minus 2 root 6 is negative 4 root 6. Oh, that was a bit obnoxious. Root 6 plus 4. And on the bottom, I have 6 minus 4. That gives me 2. And then you can see, actually, here we have 6 plus 4. We can combine that to get 10 minus 4 root 6 all over 2. And then we know 10 divided by 2 is 5. 4 divided by 2 is 2. And that's our final answer right there. 5 minus 2 root 6. So we've rationalized the denominator, and we simplified the expression there. On to the next one. The next one, we have 1 divided by 1 minus root x, or square root of x. So we want to multiply the top and bottom by the conjugate. We do this only if we're trying to rationalize the denominator, and the question asked us to rationalize the denominator. So we're going to multiply by the conjugate, so it'll be 1 plus root x and 1 plus root x on the top as well. So when we do that, the top is 1 multiplied by 1 plus root x, so it's just going to end up being 1 plus root x. On the bottom, once we start to get to know how this works, you can see that on the bottom we're going to do 1 times 1 is 1. And then we have a negative and a positive, so we're going to end up with a negative. and x times root x times root x is just going to give us x. So there is normally more, we have to FOIL it, but those middle terms cancel every time, like in this one. So what we can do is just multiply the first ones together and the second ones together and make sure we have the sign correct. I mean, it's always going to be a negative, right? Because it's one's a negative, one's a positive. It's the conjugate. So now we can... Oh no, we can't. That's as far as it goes. We can't simplify any further. That's our final answer right there. I don't think we can we? No, doesn't look like it. This is as far as we go. See, and you can tell it's been rationalized because there's no square root sign anywhere in the bottom. All right. Oh, sorry. It's got a lag, so I can't tell where I scroll. Here we go. Express root 8 minus root 3 divided by 4 root 3 minus root 2 with a whole number in the denominator. So this whole number in the denominator is like saying rationalize the denominator. So we have root 8 minus root 3 all over 4 root 3 minus root 2. And now we want to multiply both top and bottom by the conjugate. So I'm going to multiply by 4 root 3 plus root 2. And again, the same thing in the top. So in this case, we can do the top first if you'd like. So we're going to FOIL it. First term, 8 multiplied by 4 root 3 is going to give us 4 root 8 times 3 is 24. And now the outside, FOIL, right? F-O-I-L. The outside terms are root 8 multiplied by root 2, which gives us a positive root 16. And the inside terms, negative root 3 multiplied by 4 root 3. So we are going to get negative 4, and then root 3 times root 3 just cancels down to 3, which is nice. It becomes root 9, but then you can reduce it back to root 3. And then we have root 2, the last term is negative root 3 multiplied by root 2 gives us a negative root 6. There we go, that's the top. The bottom, so we're going to have, because we're rationalizing, we're going to have 4 root 3 multiplied by 4 root 3. That's going to be 16 multiplied by 3. And subtract root 2 times root 2 is just going to be 2. So now we can start to simplify. In the bottom, we have 16 times 3, which is 48, minus 2. And in the top, we want to start looking at each term. What can we do to simplify each term? So you can see here, we have 4 root 24. So we can write that as 4 multiplied by root 4 root 6. So I've split root 24 into root 4 root 6. The square root of 16 right here is just 4, which is nice. So then we can say plus 4. And then the next one is negative 4 times 3, which is negative 12. And we'll leave root 6. Can't really do much with that. Okay, so now, hopefully there's enough screen here. I'll go down to the next line here. We have 4, and then we're going to switch that root 4 into 2, root 6. Then I have plus 4 minus 12 right here. So I'm going to just combine those. Plus 4 minus 12 is minus 8 minus root 6. And in the bottom, we have 48 minus 2 is 46. And then we can deal with this term right here still. It's not completely done. It's going to be 8 root 6 minus 8 minus root 6 all over 46. And you can see here that we have some like terms. We have 8 root 6's minus a root 6. So that's going to give us 7 root 6's. We still have a minus 8 there. That comes from right there. And it's all over 46. And I think that's as far as we go. So we've rationalized the denominator. We've got our whole number in the denominator. That's what it asked us to do. So these problems, they're quite long. Make sure you're going through it step by step and double checking things, right? Maybe if you're multiplying radicals is not super awesome, go back and practice that and make sure you're really good with it, because we're doing this, we're multiplying radicals together a lot. So it's good to feel solid with that skill before you start rationalizing things, because as you can see, the expressions get quite large. So you need to be comfortable with it, rewriting your steps so that you don't lose anything or forget a negative sign. Cool, I think that's it for the notes. Pretty short one today. We're done everything with radicals. So that's as hard as it gets. That's the boss battle of these 2 units. Thanks for watching. Don't forget to like and subscribe.